What if you could see inside Apple's most secretive factory? Join us as we unveil the hidden world behind the iPhone 16's creation, from raw materials to the device in your hands. Welcome to Explained Universe. In today's video, we're diving into the fascinating world behind one of the most anticipated tech releases of the year, the iPhone 16. Don't forget to subscribe. This device, set to redefine smartphone technology, has a production journey spanning over 500 miles and involving multiple countries. The iPhone 16's manufacturing process represents a significant shift in Apple's strategy, with production now split between India and China. The global supply chain for the iPhone 16 is a complex network sourcing rare earth elements and other critical materials from various nations. This intricate web of suppliers and manufacturers highlights the international collaboration required to produce Apple's latest marvel. As we explore the iPhone 16's creation, we'll also examine Apple's commitment to sustainability, aiming to make every product carbon neutral by 2030. This ambitious goal is reshaping how the iPhone 16 is produced, balancing cutting-edge technology with environmental responsibility. The iPhone 16's advanced features rely on a handful of rare earth elements, most of which come from a single country. This geopolitical reality shapes not only the device's capabilities, but also its production challenges. China, the world's largest producer of rare earth elements, plays a crucial role in Apple's supply chain for the iPhone 16. The journey of these rare materials begins deep within the Earth's crust. Mining operations extract these valuable elements, which are then processed and refined into usable forms. These refined materials are essential for creating the high-tech components that make the iPhone 16 a technological marvel. One of the most significant advancements in the iPhone 16 is its camera system. The device features a 48-megapixel ultra-wide camera, a substantial upgrade from previous models. This camera relies on rare earth elements for its advanced optics and sensor technology. The new 5x telephoto lens also incorporates these materials, enabling enhanced zoom capabilities without compromising image quality. The A18 chip, the powerhouse behind the iPhone 16's performance, is another component that depends heavily on rare earth elements. This chip is responsible for the device's rapid processing speeds, efficient energy consumption, and advanced AI capabilities. The global sourcing of materials for this chip highlights the complex nature of the iPhone 16's supply chain. Apple's reliance on China for rare earth elements presents both opportunities and challenges. While it ensures access to these critical materials, it also exposes the company to potential geopolitical risks. This dependence has prompted Apple to explore alternative sources and invest in recycling technologies to reduce its reliance on newly mined materials. The ultra-wide camera's improved low-light performance is a testament to the innovative use of these rare materials. With a wider f2.2 aperture, the camera can capture more light, resulting in clearer and brighter images in challenging lighting conditions. This advancement is directly linked to the specialized materials used in the camera's construction. Another technological leap in the iPhone 16 is the implementation of advanced microlens technology in its display. This innovation enhances both brightness and power efficiency, contributing to a superior visual experience and longer battery life. The materials used in these microlenses are carefully selected for their optical properties and durability. The initial processing of raw materials into usable components is a critical step in the iPhone 16's production. This stage involves converting rare earth elements into the precise forms needed for the A18 chip, camera modules, and other advanced features. The complexity of this process underscores the technological sophistication of the device. One of the most impressive capabilities of the iPhone 16 is its ability to record 120 frames per second in 4K resolution. This feature is made possible through the integration of advanced materials in its camera and processing components. The seamless coordination between hardware and software, enabled by these rare materials, delivers unprecedented video quality in a smartphone. As components arrive at Apple's factories, a new chapter begins in the iPhone 16's journey. What happens when humans and robots join forces on the assembly line? The integration of artificial intelligence with human ingenuity creates a manufacturing process that pushes the boundaries of what's possible in mass production. The assembly line for the iPhone 16 is a testament to precision engineering and advanced robotics. Sophisticated machines handle tasks requiring extreme accuracy and consistency, such as placing microscopic components on circuit boards or applying adhesives with micrometer precision. These robots work tirelessly, ensuring each iPhone 16 meets Apple's exacting standards for quality and performance. However, the human element remains crucial in the production process. Skilled technicians oversee the robotic operations, making adjustments and performing quality checks that require human judgment and expertise. These workers are essential for tasks that machines cannot yet perform effectively, such as final inspections and intricate adjustments that demand a keen eye and delicate touch. The integration of various components on the assembly line showcases the complexity of manufacturing the iPhone 16. Camera modules, the A18 chip, and other advanced features are carefully placed and connected, forming the heart of the device. The new vertical camera orientation in the iPhone 16 and 16 Plus models presents a unique challenge, requiring precise alignment and calibration to ensure optimal performance. One of the most significant innovations in the iPhone 16's design is the new action button. This feature, slightly larger than in previous models, allows users to assign custom actions such as launching apps or activating the flashlight. The integration of this button into the device's frame requires careful assembly and testing to ensure its responsiveness and durability. The capture button, another new addition to the iPhone 16, exemplifies the fusion of hardware and software innovation. This button enables users to hold to focus, press to take a shot, and slide to zoom, providing a more intuitive photography experience. The precise installation and calibration of this button are critical to its functionality, demanding a combination of robotic precision and human oversight. Throughout the assembly process, quality control measures are implemented at multiple stages. Automated systems perform rapid tests on individual components and partially assembled devices, while human inspectors conduct more nuanced evaluations. This multi-layered approach to quality assurance helps maintain the high standards expected of Apple products. The final stages of assembly involve the installation of the battery, the attachment of the display, and the sealing of the device. These steps require a delicate balance of automated precision and human skill to ensure the iPhone 16's water resistance and structural integrity are not compromised. As the last screw is tightened on the iPhone 16, a question looms large. Can a smartphone be both a technological marvel and an environmental ally? Apple's approach to this dilemma reveals a complex web of sustainable practices and energy-intensive AI technologies. The company has set an ambitious goal to achieve carbon neutrality across its entire supply chain and product lifecycle by 2030, including the iPhone 16. This commitment has led to the implementation of several sustainable practices in the manufacturing process. One of the key initiatives is the use of renewable energy sources in production facilities. Apple has been steadily increasing its reliance on clean energy, reducing the carbon footprint of each iPhone 16 produced. Additionally, the company has made significant strides in incorporating recycled materials into its products, further minimizing the environmental impact of resource extraction. The elimination of leather from Apple's product lineup and the reduction of plastic in packaging demonstrate the company's broader commitment to environmental responsibility. These changes extend beyond the iPhone 16 itself, reflecting a holistic approach to sustainability that encompasses all aspects of the product ecosystem. However, the integration of advanced AI technologies in the iPhone 16 presents a new challenge to Apple's sustainability narrative. AI systems require substantial computing power and electricity, potentially increasing the device's energy consumption. A peer-reviewed analysis has raised concerns about the significant contribution of AI technologies to carbon dioxide emissions, complicating Apple's efforts to balance technological advancement with environmental stewardship. To address these concerns, Apple is implementing energy efficiency measures alongside the enhanced features of the iPhone 16. The Pro models, expected to feature faster charging capabilities, are being designed with a focus on minimizing energy use without compromising performance. This balancing act between improved functionality and reduced environmental impact is at the heart of Apple's sustainability strategy for the iPhone 16. The company is also exploring innovative solutions to offset the carbon emissions produced by its AI technologies. While the exact measures remain unclear, Apple has indicated plans to plant trees and invest in other carbon offsetting initiatives. These efforts aim to mitigate the environmental impact of the iPhone 16's advanced features, aligning the product with Apple's broader sustainability goals. The iPhone iPhone 16's enhanced battery capacities and faster charging speeds present another challenge in the sustainability equation. While these improvements offer tangible benefits to users, they also have the potential to increase overall energy consumption. Apple's approach involves implementing energy efficiency measures in tandem with these advancements, striving to deliver improved performance without a proportional increase in environmental impact. The iPhone 16 represents a significant leap in smartphone technology, powered by the A18 chip and featuring advanced AI capabilities. Its upgraded camera system, including a 48-megapixel ultra-wide camera and 5x telephoto lens, promises exceptional image quality and enhanced low-light performance. The new capture button and action button offer intuitive controls, improving user experience. The manufacturing process behind the iPhone 16 is a testament to global cooperation and technological innovation. From rare earth element extraction to the final assembly, each device embodies the efforts of countless individuals across multiple countries. This international collaboration enables the creation of a device that pushes the boundaries of what's possible in mobile technology. As consumers, it's crucial to consider the environmental impact of these advancements. Apple's commitment to carbon neutrality by 2030 highlights the complex balance between technological progress and sustainability in the production of cutting-edge devices like the iPhone 16. Thanks for watching Explained Universe. If you enjoyed learning how the iPhone 16 is made, don't forget to like, subscribe, and hit the bell for more tech breakdowns. See you in the next video.